Hello, I thought we'd have a look at the 13 addressing modes of the 6502, given the fact that the next phase of coding starts to tackle some of these and starts to look at some of the instructions and how we can, how we can make code that actually deals with the addressing modes in the 6502. There are 13 of them, as said, and the first one is implied or implicit. You'll sometimes see it as written as implicit, and that means that the actual instruction, the mnemonic here, in this case increment x, implies the function, because what you're saying is I'm going to increment x. Well, okay, so we kind of guess what that's going to do because you're working with the x register and you're incrementing it by 1 like that. Implied instructions are 1 byte, 8 bits, as are the accumulator instructions, but the difference being that the accumulator instructions all work on the accumulator. And sometimes, these things can have actual other addressing modes, and you'll see that later on. But there's no implication within the instruction name, i.e. that says ASL, that's arithmetic shift left. But when you're arithmetic shift left what if you don't know that it's an accumulator instruction? But given the fact that we know it's an accumulator instruction and we know that an arithmetic shift left effectively multiplies by 2 in binary, therefore the accumulator now equals 4. The indirect addressing mode only ever applies to one command, the jump command, so I've highlighted it here in red within the 6502. There is no other instruction that uses indirect addressing. And indirect addressing says if you were to leave the brackets out there, the parens, what we would actually say is go and jump to address 200 in hex. But what you're actually saying is actually that's not what I want you to do. I want you to go and fetch where I need to jump to from address hex 0200. So it goes down to here and says that's the low byte because it's little endian, and that's the high byte. So post this instruction, the program counter would actually equal 0300 because it's taken the addresses in indirect, so it jumped to 200, had a look what was in there, took the low byte, put it in here, then took the high byte and put it in here. So that's how indirect works. Relative, well, this addressing mode applies to all the branch instructions. What the branch instruction says is jump relative to my location. Now, the funny thing to remember is that it works in 2's complement binary, so you can only jump 127 paces forward or 128 paces backwards from the current program instruction. So if we set the program instruction to something else, if we set the program instruction effectively back to where it came from, 0008, so that's on the 0th page and the 8th location, which there's nothing in it at the minute. It doesn't actually matter that there's nothing in it. But what this says is jump backwards 2 places there, or if you change that to a positive number, say 6, that says jump forward 6 places, so 1, 2, 3, 4, 5, 6, and it would start reading that as the next instruction to execute. There's quite a lot of resources out there for how 2's complement numbers work, but in reality the way it works is that the sign bit or the negative bit is the high bit, and if the sign bit is set then the number's negative, and if the sign bit is not set then the number's positive, and that's kind of what we did there. So an immediate instruction, what that says is, we've seen these before actually, what that says is take that value there, that 0f, and pop it into the accumulator. So post that instruction you would have the value of 0f in your accumulator. The 0 page instruction, well, these are quite interesting because these are only 2 bytes long, okay, because the actual first byte of the 0 page, the 00 bit here, is implied in the instruction. So it says, and so these instructions execute a lot quicker. So what it says is go and fetch, in this case it says go fetch the contents from address 2 and pop it into the accumulator. So post that instruction there, you would have the accumulator would hold a value of DD. Okay, now 0 page X and 0 page Y, they're the same except that they use the X or the Y register as an index, an offset if you like. So therefore, if the X register here is equal to 1, then that would actually say go load my value from 2 plus 1. So 2 plus 1 is 3, and post that instruction, the accumulator would equal EE. And similarly, the Y instruction does exactly the same. The Y index does exactly the same. The only thing is, you can't. The reason why they use both is because you can't, for example, use an LDX instruction and use the X register as an index at the same time. So LDX, you need to use the Y register, and LDY, you need to use the X register. So you've got two modes which effectively do the same thing for different registers. Absolute, well, that says, look, take the contents of whatever's in there. So in this case 0492, which is down here, 19, and it says put that contents into the accumulator. And as you can see, those instructions are actually 3 bytes long, because they're taking the full range of the address, the full 16-bit address. So they're slightly slower to execute than the 0-page instructions. And again, absolute X and absolute Y, they do the similar thing as the 0-page X and Y. They use the X and Y registers as an index, and in this case we're saying store the contents of the accumulator into the address of 200 or 200 hex actually, and offset it by the X register. So in real case, what it's saying is X is 1, so it's 200 plus 1, and therefore we would actually put the contents of the accumulator in there, and that would then end up equaling 19, like that. Okay. We'll set that back. We'll set that to something else. It doesn't really matter, because we can play about with these as we go along. But that's what that would do. And the same thing here with the STX. You're using the Y register for the command that applies to the X register, because you can't use X and X. Now these two bottom ones, these are the strange ones. What they're strange because they're just the same thing in reverse, aren't they? In indexed indirect and indirect index. It's like, yeah, great. What the heck do they do? Well, the answer to the question comes from the brackets, or the parens, if you like, in the command. And this one says, load the accumulator from the value of D plus X, and it's a 0-page wraparound. Yeah? So D is there, X is 1, that is there, right? So you load the accumulator. Sorry, you don't. What you do is you take that value there, that 02, and that value there of 02, and you add them together in the Pro, and it becomes 0202. So it actually says go load the accumulator from here. Okay, so that means that the accumulator would equal 3 post that command, or 03 if you like. Yeah, and post that command, that would be what the accumulator would equal. So if we go through that again, it says add X to 0D, and because X is 1, there we go, 0DE, and then go and get those, then take that as the low, that as the high byte, little endian again, and go load the accumulator from that address. It's not often used, but it's there to be used. Okay, so this one on the other hand doesn't do that. What this one does is this one says take the address at 10 or hex 10 and hex 11. There's hex 10 and there's hex 11. Little endian again. So 0492. So go fetch 0492 plus Y there. So in this case it would be 0493, and put that into the accumulator. So in this case the accumulator would equal 32. And this one is used more regularly because you can use this one kind of like for arrays. Because if you think about it, the way that you would do an array is you would say get me the base address of the array. Well, the base address is stored in 0 page, it's here. and then use the Y register to index me into that array. So if the Y equals 0, then 4092 would be the address, and then Y equals 1, so it's 4093, Y equals 2, it's 4094. And they are probably the most complicated addressing modes on the 6502, but they're not that difficult when you actually start to think about them, and certainly they're not that hard to implement within C. So this pretty much has been a brief overview of what the addressing modes are, and in the next set of videos we'll start looking at how you implement them within the emulator.